Hey, hi everyone. Welcome back to my YouTube channel. My name is Sunny Savita and I'm back with another exciting and important video. So in this video, guys, we'll see how we can fine tune the BERT model. BERT is one of the classical NLP model which is being used for a different NLP tasks like question answering, summarization, text classification, and many more. So guys, as you know, I started with this LLM fine-tuning playlist where I uploaded almost 8 video regarding the fine-tuning concept. In the very first video, I discussed the complete syllabus, and in the remaining video, I discussed the different concept of the LLM fine-tuning. Each and everything I cover up from very scratch. So if you want to start your fine-tuning journey, then for sure you can visit these particular videos. In the previous video, guys, I discussed the HuggingFace, the complete HuggingFace in a single video. HuggingFace is a very important framework if you want to learn NLP, LLM, generative AI and all. So in this particular video, I explained how you can basically load the different models, how you can load the different embedding model, what is a HuggingFace API, HuggingFace langchain and all. So if you haven't checked so far, please go and check with this particular video. In the playlist section, guys, I created a playlist as well, so there you will find out all the video in a single shot. The playlist name is complete LLM fine tuning playlist. So guys, before coming to the concept, let me explain you the let me give you the walkthrough of the syllabus, and let me tell you that why we are going to be cover this BERT fine tuning. So guys, this is the complete syllabus which I am going to be discussed throughout this particular playlist. So in the very first video, I already discussed about the syllabus in detail. If you haven't checked, please go and check. So let me give you the quick glimpse of it. So we already discussed about the introduction of the fine tuning in a very detail. Then we understood about the fine tuning versus RAG versus AI agent. Then we understood about the fine tuning in deep learning, fine tuning in CNN architecture, fine tuning in NLP, right? Then we understood why fine tuning is not possible in a classical RNN LSTM, what was the challenges and all, everything I discussed over there. Then HuggingFace versus langchain. So in the last video, we discussed about the complete HuggingFace. Along with that, we discussed about the HuggingFace versus langchain, and basically how we can utilize this HuggingFace with the langchain as well. So if you haven't checked, guys, please go and check with that HuggingFace tutorial. Then now we are going to be discuss the fine tuning of the classical language model, that is BERT. This is important because with that your ground concept is going to be clear, and in interview they might ask you some question from here itself. After this one, guys, will come to the concept of the knowledge distillation, LLM quantization. So this is also very important concept if you are dealing with the fine tuning, if you are going to perform the fine tuning. So for sure you should be aware about some side concept like knowledge distillation and all, so that you can utilize it for better model, for better training of the model. Okay, then guys, here after this one only will come to the LLM fine tuning. So in the LLM fine tuning, we'll understand about the fine tuning of the Llama, Mistral, Llama, V5.3 and all. So different model I'll show you. Apart from that, the different concept of the LLM fine tuning like LoRa, QLoRa, DORA, RFT and all. So these are all the topics we are going to be discuss. We're going to discuss about the different framework also, like Llama Factory, Unsloth, Axolotl, and basically different other framework which is required to perform the fine tuning. Okay, then guys, we'll come to the fine tuning of the API based model. So GPT, Gemini, Cloudtail, like how we can fine tune those specific model. Fine tuning of the vision based model, right? So BIT, Florence, Quan. So these model how we can fine tune using the different framework, I'll show you that. Then RLHF concept, preference optimization, direct preference optimization, then we'll discuss about these. And here I even included the embedding fine tuning as well. So this is the complete syllabus, guys, and inside this syllabus intentionally I capped this fine tuning of the classical model so that your concept from scratch could be clear, and then we can start with the advanced concept of the fine tuning. So I hope it is clear now. Without wasting a time, let's start with the BERT fine tuning concept, guys. So this is the research paper of the BERT, guys. As you can see, the BERT model was published in 2019, 24th May 2019. So the full form of the BERT is pre-training of deep bidirectional transformer for language understanding. So Google has published this particular research paper. If you want to understand and if you want to deep dive into the BERT, then please go and check out with this research paper. There they have explained you each and every concept related to that, and apart from that you will find out each and every benchmarking result also over here. So what I will do, guys, I will not go in a mathematical intuition of this word as of now. For that, I will launch a separate series. In that particular series, I will show you the LLM, the different LLM a transformer, and how this bird also have been trained. So that will be a separate series, but in this particular video I will give you the complete overview of this bird, the functional overview. For that I already capped some architecture and all on my blackboard. So let me give you the functional overview of this bird, so that whenever any question is coming in an interview, so you can answer that particular question in a better way. And for the remaining intuition, the mathematical intuition, first we'll have to go through with the transformer architecture, then only we can understand this bird. So that is going to be a separate series, separate video, which I will launch soon. So this is the complete code, guys, which I'm going to teach you in this particular video. So here I capped the fine tuning of the BERT. After that we are going to perform the prediction using the BERT model. Then we are going to push it to the HuggingFace hub, and not only for the one single task. I'm going to be fine tuned this BERT model for the several different tasks. So I capped the code for the text classification, then I capped the code for the NER. Here you can see this is my NER data. Then after that I capped it for the QA also. So here I shown you how you can fine tune the BERT on a different type of data, on a different task, so that your each and every concept is going to be clarified and you can utilize it for any sort of a task. So this is a generic code which I capped over here. See here, basically if you are going to be choose 1 2 3 4, based on that, according to that only it's going to be perform the fine tuning on your specific data set. Okay, so before coming to this code, let me give you the quick overview of the BERT model, so that you can understand it in a better way. So I hope my blackboard is visible now. So over the blackboard, guys, I capped a couple of images, as you can see. So BERT base, right? So if we're talking about the BERT, guys, so BERT is having two variants. So the first variant of the BERT is called BERT base, okay, and the second variant of the BERT is called BERT large. So first of all, if we're talking about this BERT model, so this BERT model actually it's a encoder based model. If you don't know about the encoder, so it is a part of the transformer architecture. Okay, so BERT base, which is where you have 12 encoder, and if you're talking about the BERT large, so there you will find out in total 20 encoders. Okay, so guys, here in one more architecture you can see the transformer. Okay, and not only the transformer, so here I shown you the transformer. The first part of the transformer is a BERT, right, that is encoder, and the second part of the transformer is a GPT, that is decoder. So GPT is a generative model. So GPT, what is a GPT, guys? So GPT, we're talking about the GPT, so it's a generative model. So whatever model you can see nowadays, whatever LLM model, so those LLM model actually it is a generative model, right? Now if talking about the BERT, so BERT is not a generative model. So this has been trained on a different sort of a task. So the task basically was the MLM, or the task was the NSP, next sentence prediction. Okay, so using this one, we were trying to solve some sort of a problem statement like text classification. Okay, we are trying to solve like question answering, we are trying to solve summarization. Okay, or we are trying to solve like NER or POS tagging kind of problem statement, right? So guys, the today's LLM, right, the today's LLM like the GPT, Cloud A, DeepSeek and all, so those LLM basically again it is using this GPT concept, like auto regressive training concept. auto regressive training concept. There we are trying to predict the next word in the given data. Okay, next word in a given data, and with that actually we are trying to perform the auto regressive training, and those specific model is called the generative model. Nowadays this BERT is not being used too much, but at couple of places still it is being used. I'll show you those places, okay, those tasks, for those particular tasks, for which task this BERT is being used. Okay, I'll talk about it so that you can clearly understanding the requirement of this BERT model. Okay, now I hope this is clear. This thing is pretty much clear to all of you. Now coming to the couple of more concepts. So as I told you, this BERT is nothing. This BERT is a encoder based model. So here is a one more architecture. Let me keep it over here, this one. So as I told you, in a BERT based model, we have 12 encoder. Okay, 12 encoder you will find out, and we're talking about the BERT large model, so in that you will find out 24 encoder. All right, so this encoder is nothing. This encoder basically it's coming from the transformer architecture. So transformer is having two parts. So first part of the transformer, first side of the transformer is called the encoder, and the second side of the transformer is called the decoder. Okay, decoder. So guys, this all the thing, this all the topic, this entire detail I even explained in my previous videos. If you don't know about it, you can go and check out with this particular video. Let me highlight that as well, so that you can learn this thing in a better way, in a very detailed. So just go and check with this video, LLM fine-tuning, why fine-tuning was not possible in RNN and LSTM. Apart from that, you can check out with this transfer learning and fine-tuning, theory and practical, video number 3. There also I discuss couple of points related to that. Even this LSTM and transformer, I just given you the like the glimpse of this BERT based model. Okay, so here guys, you understood about the BERT, right? What is a BERT? BERT is a encoder based architecture of the transformer. In the base model there is a 12 encoder, and the large model there is a 24 encoder. If you will go and check with the previous video, I shown you all this encoder and all everything, your idea will be more clear. Okay, so this thing we already understood. Now let me explain you one more thing with respect to this BERT guys. So I kept one more architecture for all of you. So here inside this particular architecture you can see, so whenever we're talking about the BERT kind of model, so you understood this BERT is nothing, it was built on top of the transformer. Okay, now this BERT is an encoder, right? This BERT is an encoder of the transformer. Now there is a two training stage of this BERT. So first stage of this BERT is called the unsupervised pre-training. Unsupervised pre-training. Okay, and the second stage of the training is called supervised training. Supervised training. Okay, first stage is called unsupervised pre-training. This is also called self-supervised training. Okay, self-supervised training. If you don't know about it, you can go and check out with my previous video. I explain you over there. So here it has mentioned semi-supervised, but this is not a correct word. You can say it is a self-supervised pre-training or unsupervised pre-training. Now in that, what we are doing, we are going to be collect our data from the various resources from the entire internet, right? So what is the objective of this particular stage? To collect our data from the various resources and to perform a training of this BERT model. Now how this training is being performed? So using this MLM technique, MLM means mask language modeling, and NSP technique. NSP means next sentence prediction. So if someone is going to ask you that how this BERT model have been trained, so you can simply say it has been trained on top of this mask, using this mask language modeling technique. Okay, and it has been trained using this next sentence prediction technique. Okay, next sentence prediction technique. Now after that guys, so after training this BERT model on a very huge amount of data, okay, so why it is called unsupervised pre-training? It is called unsupervised pre-training because we are going to be collect our data from the various resources from the internet and all, and this data basically it was not a labeled data. Okay, not a labeled data. It was not a labeled data. Because of that, it is called the unsupervised pre-training. Now down the line, guys, so this BERT model have been trained for some specific task. So in the research paper they have mentioned, so let me tell you this as well. So at the first place, they have took the huge amount of data, okay, from internet, okay, and after that, guys, they have performed. So this stage is called the unsupervised pre-training, as you know about it, right? As I told you, unsupervised pre-training or self-supervised learning. Okay, the second stage is called the supervised training. So guys, if you're talking about the supervised training, right, so down the line this particular model have been trained on supervised data, and the task basically was a text classification. If we are going to be train any model normally on directly on this particular task for the text classification in 2019, in 2018, right? So the LSTM model also was being used. So what we were doing, guys, so this LSTM model directly we were training. Okay, in the LSTM, using this LSTM, we have created one very famous architecture. The architecture was the encoder decoder architecture. Okay, and encoder decoder were attention architecture, and we were training this particular model for the text classification. But guys, when this transformer have been invented, okay, when the transformer have been invented, this transformer, what it has done, you know, it has replaced all the LSTM based model, because here we were having some constraint. This constraint I have explained you in my previous video. You can go and check over there. So this transformer based model have replaced all the LSTM based model. And first what we have done, we have took the data, huge amount of data from the internet. We have trained the transformer based model, okay, like encoder or decoder based model. And then down the line, like for the downstream task, we have performed the supervised training again. So the accuracy we were getting at that time, that was much better compared to this LSTM or encoder decoder LSTM based model. I hope this thing is clear to all of you. So this image is defining, or this image is explaining the same thing. Now see guys, there could be a mathematical intuition also regarding this transformer, GPT and BERT. So that we'll understand in some upcoming videos, some upcoming sessions. Okay, so as of now, we are just going to be understand this entire thing as on a functional level. Now for what are task we are going to be fine tune this BERT model. So let me highlight the task over here. The very first task, what we are going to be we are going to be perform the text classification. Okay, I'll show you like how we can like fine tune this BERT model using for the text classification task. Then I'll show you for the NER also. Okay, then I will show you for the QA, question answering. Now one more thing you have to be remembered. See, this BERT model is not a generative model. Okay, generative model, right? Generative model, GPT model is a generative model. This BERT model is not a generative model. If someone is going to ask you in an interview, you can highlight this particular thing. So guys, how the thing is working, how the thing is happening, let me tell you that as well. So inside this architecture, you can see this one more architecture I kept for all of you. Let's say here we are giving a sentence. Okay, this is my sentence, and the sentence is going through the BERT model. This is my BERT model. So BERT is what? BERT is nothing, it's a stack of the encoder. Okay, as you know, like it's a stack of the encoder, transformer encoder. So guys, what we'll do, see, we'll pass the sentence to this BERT model. It is a stack of the encoder. Okay, if we are taking a BERT-based model, so there we will be having 12 encoder set. Now after that, guys, see what will be there. So there will be a head. Okay, so if we're talking about classification, so for the classification there will be a different head. Now if we're talking about the QA, question answering, so for that there will be a different head, okay, on top of this encoder. If we're talking about the summarization, so for that there will be a different head. Now if we're talking about this head, guys, so this head is nothing. If we're talking about this head, so this head is nothing. It is what? It is a feed forward. It is a feed forward neural network. Okay, it's a feed forward feed forward neural network. Okay, feed forward neural network. This is also called a dense network. Okay, dense layer, dense network. So anything you can say dense network. Okay, and along with that you will find out the softmax also will be there. So head, if you're talking about the head, guys, so on top of the encoder, if you will look into the transformer architecture, so this is the transformer architecture, guys. As you can see inside this particular architecture, okay, if I'm going to copy this particular like image, and if I'm going to be paste it over here, you will be able to see clearly that inside the encoder, okay, over the encoder we don't have anything, right? So here is an encoder. So this is just a, this is the encoder stack. Now likewise you can keep a 12 stack, right? But here you can see we don't have anything at the end to predict, right? So at the end to predict we don't have anything. Simply we will be getting a vector, the process vector, the contextual vector, after going through from this particular stack, the encoder stack. So in the encoder stack, what we would be having? So we are having like input, then positional encoding. Okay, after the embedding, there is a positional encoding, then multi-attention, and then feed forward network, and then residual connection and all for sustaining the context. Okay, and then whatever output we are getting from here, it will go to the another encoder block. Okay, then whatever output we are getting from here, it will go another encoder block. Okay, likewise this thing is going on as like the number of block, right? As many as the number of block have been defined. So in BERT-based we have a 12 block only. Now guys, see over here, if we are going to talk about, right, so what we are getting a simple contextual vector after the encoder. Now on top of it we are going to place the head for what? Head for generating a final output. So in the head, what would be having? In the head we would be having neural network plus softmax function, and this head is going to be changed according to the task. If it is a classification task, so this head is going to be different. Okay, if there is a question answer task, this head is going to be different. If there is a summarization, then head will be different. If there is a NER NER or POS stacking, this comes under the token classification, right? So the head is going to be different. Okay, so while we are going to be understand the mathematical intuition of it, we can more talk about this head and all. I hope this particular thing is pretty much clear. Now let's do one thing. Let's try to start with the practical of the BERT fine tuning, and let's see how basically we can perform the fine tuning of the BERT model. So guys, before starting with the practical, let me clarify one more theoretical concept, and the concept is where BERT is still being used. So the answer is BERT is still being used at multiple playlists in a different form. So here I listed couple of points, and let's try to discuss this point step by step, because it might be useful when you are going in an interview. People might directly ask you this kind of thing. So the first thing is a search and a retrieval. So guys, we are going to build a RAG. RAG is very important concept in the generative AI. So using the capability of the LLM, right, we can build the RAG on top of it. Means we can connect this, we can connect the external data source, okay, with our LLM, and then we can generate the final output. That is a RAG. If you don't know about this RAG, you can go and check out with my YouTube channel. There I already uploaded so many video regarding this RAG. Okay, so whenever we're talking about the RAG, guys, so inside that we are going to be perform this data ingestion. Okay, data ingestion. In the data ingestion, what we do, whatever data we have, we are going to be like put this particular data in the vector database. Okay, in the vector database. Now this particular data will be available in the form of embeddings, right? Embeddings. So as I told you guys, this transformer based model, this transformer based BERT model, right? These particular model is being used for creating a embeddings. Okay, using this BERT model, we are going to be create a embedding. So as you know, right, so the BERT is based on top of the encoder of the transformer. In the encoder, we have two things. The first is called the self attention, which is very good to understand the contextual meaning of the sentence plus feed forward neural network. Okay, so using this particular concept, like whatever vectors we are getting, so this vector, instead of doing a classification directly on top of it, instead of doing the question answering, we are not doing this thing on top of this particular vector using any head. Directly we are using this particular vector as a embedding. Okay, if you don't know about this thing, I already explained you this particular concept in my previous video. I even shown you the practical. So here I mentioned this BERT model. It is being used for the vector, for generating a dense vector. Okay, the sentence vector. We are going to be stored in a files, and we are going to be use it in a RAG pipeline. I hope you understood it. Now LLM, this BERT, it is still being used for some enterprise NLP level of task for fast and the cost effectiveness. If you're talking about the LLM, guys, so with the LLM some cost is associated, but if you're talking about some classical model like BERT, Robert, DistilBERT, XLM and all, so in that, this model, first of all, this model is open source. This is like taking out less space compared to the huge LLM model. Okay, and it is easy to configure, right? We can configure it on any basic configuration or any basic infrastructure. That's why this particular model is still being used for any small NER tasks and team analysis, which comes under the classification, summarization and all. Okay, so still you can use it, but again, if you want like a good accuracy, if you want to be rely more on this LLM, on this LLM generated answer, in that case you should think about this BERT model and all, because it is not very much trustworthy compared to the today's LLM model. It might work, but you will have to compromise. It might work faster, it might be the cost effective, but for sure this model is not a very state of art, so you will have to compromise with some accuracy and all. Okay, now hybrid pipelines with a LLM, as I told you, in a RAG architecture we're going to use it, so that is a hybrid, that comes basically in a hybrid pipeline, means we can use the LLM. Okay, we can use the LLM, and along with that we can use this BERT also for generating some embedding and all in a RAG. If you don't know about it, you can go and check out with my RAG playlist, or else you can check out with my previous video at least. So there I explain you the sentence embedding concept. Okay, sentence embedding concept using the sentence transformer. Sentence transformer is one of the library in a HuggingFace itself. There you will find out many transformer based model, sentence transformer. Okay, many transformer based model which is being used for creating a embedding. Right now the next is a multilingual NLP. So XLM model is a multilingual BERT model, okay, which was created by the Microsoft itself. It still is a top choice for the for the developer, right? If someone wants to be use the open source model. Okay, so it is being used for the translation and the cross lingual search and all, so you can export this model as well. On device low latency, if you're going to be use any edge device or mobile device with a lower configuration, in that case also for some task classification, NER and all, you can utilize this BERT model. So the moral of the story is, today in today's era, in today's world, we have so many use models, so many different model, but still this BERT is being used at some sort of a places. So these are some places which I highlighted over here, and for sure you can look into it, you can read it, and you can basically make your understanding, okay, regarding this BERT and all, that where it is being used is still in the world of the LLM. Now here I kept the name of couple of more model like BERT, DistilBERT, Roberta, DBERTA, MPNet, MiniLM, T5, FLAN, BART, Pexus, XLNet, XLMR, Electra. Right, so these particular model, guys, you can use in place of BERT. Right, so here I've shown you the fine tuning of the BERT model, but you can try out with a different other model as well. Okay, so these are some classical NLP model which was being used like 2 to 3 years back extensively. Now so here, guys, this is the complete fine tuning code. Now let's try to discuss this one. So for the practical, guys, at the first place we'll have to install couple of libraries. I'm going to be install this dataset, this FSSPEC transformer. This FSSPEC, it helps us to download any file from server to the local. So guys, here I already installed this particular package. Please install with the same command so that you won't face any sort of a error. Now after this one, what we'll do, so we are going to be import this load data set from the data set, and we are going to be import this BERT tokenizer, BERT port sequence classification, trainer, and training argument from the transformer. So yes, I'm going to be imported. Now let me tell you one more thing, guys. See, whenever you are going to be start with your training and all that, please make sure you selected the appropriate GPU. I don't have access of the paid GPU. I can purchase the Google Core Apollo and then I can get it, but as of now I have access of the free GPU and I'm going to be use the same over here. Now what I will do, see here guys, my data set and the tokenizer, BERT model, everything is being loaded now until I can show you the data. So here guys, I kept a different kind of data set for all of you. You can utilize this AG news data. Okay, you can use this DBpedia data. So this is also very huge data set, and for sure you can utilize it for performing the training, okay, the fine tuning on top of the BERT model. Now if you're talking about the real-time use cases, so in the real-time use cases from where you might get this classification data, sentiment data, I written couple of name over here. The first is a customer's feedback. So let's say you have published one form, or if you are working on a CRM if you are like working on a CRM platform, right? If you are going to be raise some support ticket and all, okay, or like if you are going to be checked with your email topic. So customer feedback categorization, whether it is a positive, negative, or neutral. Support ticket classification, whether it is for billing, technical, for any general ticket. Email topic classification means whether it's a ham or a spam, right? So what kind of email is being generated. So this could be a real-time use cases for the classification problem statement, and many of you are going to be you are going to be like solve it in your real time like use cases as well. Okay, now here I'm going to be load the data, guys. So which data I'm loading over here, I'm going to be load the IMDb data. If you don't know about this particular data, I already shown you this data, the detail of this data in my previous video. If you don't know, you can go and check over there. Okay, or else you can utilize this data if you want to work on some new data set. So now what I'm doing, guys, so after loading this data set, here you can see I'm going to take a sample, because if you will look into this data set, so there you will find out more than 25,000 sample, okay, which is a very huge as of now. To train our model, it will take much time, at least 5 to 6 hours to train on this much of data. BERT model is a huge model. Then what I will do, I will take this training data and the test data. I'm taking 1000 sample for the training, and I'm taking 500 sample for the testing. Okay, now here guys, I'm going to be load the tokenizer. So tokenizer is for what? Tokenizer to perform the tokens of the given sentence and to assign an appropriate ID to the specific token. If you don't know about this thing, guys, you can go and check out with my previous video. There in the HuggingFace tutorial, I have explained you each and everything. Okay, you just need to be check out that video. That's it. Now guys, after this one, what I'm doing, guys, so here I'm going to be like I created this particular function, tokenizer function. Inside that we have a tokenizer. Okay, it is taking example, means it is taking a text, it's performing a padding, okay, up to the like the max length sentence, and the max length how much I'm providing, 256. So there should be only 256 token in one sentence. Okay, if it is going to be more than that, it is going to be, and then those particular sentence, specific sentence, will be rejected. Truncation true, right? Yes, if the sentence is max then this 256 token, then the truncation will be true. We are going to be truncate those particular sentences, and here we are going to perform the padding according to the max length. So what is the max length? 256. Okay, so you can think in such a way that in one sentence we have 300 tokens. In that case, there could be only 2256. Now let's assume in one sentence we have 100 tokens. So how should be max? There should be 256 max token. So rest of the token, 156 token, rest of the token will be showcased as a 0 value. Okay, padding value. Now here I created one function. The function name is what? Process. So it will take the data, it is going to be map the data, okay, with the tokenizer, and after that, guys, what it will do, it is going to be written the process data. So in the process data, we are going to be change the column name, the label column name, okay, and then here I am going to be set the format. So what is the format? The format will be a PyTorch tensor, and here the column name will be inputs, attention, mask, and label. By default, the output feature name was a label, but Hugging Face required this specific name, that is labels. That's why we just have rename it. So after doing certain pre-processing, guys, what we'll do, so we are going to be utilize this data for the training. So here you can see we have this pre-process, we are passing this train data set. Okay, now here you can see I got the train data set. It's going to be map, and after performing the entire pre-processing, I'll be getting my data. See, my data was small, so it has completed within a minute itself. Okay, then here I have test data. So if I'm going to be pre-process that, instantly I will be getting my pre-processed data, because the data is very less. If we have 25,000 rows, 30,000 rows, 1 lakh rows, it might take some time in that case. Okay, now what I'm doing, guys, I'm going to be load my model. So here like my model is getting loaded. Okay, so what I have passed my model name, and here is my number of labels. So in output class, how many labels should be there? So there are only 2 labels. Now, guys, if you want to check out the detail of this particular models, number of label and all everything, so I already discussed in my previous video. As I told you, please visit this video, fine-tuning introduction, transfer learning and fine-tuning. Okay, fine-tuning LSTM versus transformer. This video is a very important and the most important video. So I would highly recommend you all this video if you want to be pro in the field of fine-tuning. Okay, now what I'm doing, guys, see here I written couple of more code. So whenever we are talking about BERT, okay, so as you know, guys, BERT is a transformer based model. We have seen the base variant of the BERT where we are having 12 encoder, 12 encoder, and we are having the large variant of the BERT. So there we were having 24 encoder. Okay, now, guys, see, whenever we are going to fine tune it, now what is the meaning of the fine tuning? So fine tuning means we are going to be retrain the model, Now, guys, this retraining, if we're talking about the retraining the model on our own data. Okay, now whenever we're talking about this retraining, guys, so there could be 2 parts of it. There could be a full retraining. Okay, there could be a couple of layer. Okay, selected layer, or there could be a last layer, last output layer. This all the thing I clarified in my previous video. You can go and check out. So if we're talking about the BERT model, so in BERT model, this full fine tuning is also possible with a small learning rate. Okay, we can fine tune some selected layer. So this I already taught you in my previous video. You can go and check how to fine tune the BERT on some selected layer. Last output, this also I have taught you in my previous video. Okay, previous video. Now what we're gonna see, guys, we're gonna see like how we can fine tune the BERT model with the small learning rate. Okay, on our own custom data. But guys, let's say if I don't want to be fine tune all the layer, right, all the base layer, all the 12 encoder layer, all the 24 layer, right, in that case we can select some custom number also, like last 2 layer, right, last 2 layer. We can select some last 5 layer. It's up to me how many layers I want to be fine tuned. I hope this is clear. Now whenever we're talking about, guys, the other model, so if we're talking about the large language model, the huge LLM model means what? Let's say GPT model, or Llama model, or let's say Mistral model, or cloud-based model. So guys, this model, like, you cannot fine tune the last couple of layer of this model, or you cannot fine tune the full encoder or decoder stack of this model. It's not at all possible. So for this one, we have some other technique. So we'll understand about the LoRa, Q-LoRa. In Q-LoRa, the quantization comes. Okay, quantization. Q is representing the quantization. We'll have to understand the LoRa, then quantization, then we'll understand about the Q-LoRa. So this technique comes under PEFT, P-E-F-T. Okay. So with BERT model, we can fine tune the all the layers, okay, on our own custom data with a small learning rate. But in use LLM, some state art SOTA model, right? State of art SOTA model. It's not possible. So this thing we'll see in our upcoming sessions. I hope this is clear. Now what we are doing, see, I kept that code as well. If you just want to be fine tune the last two layer, you can utilize this code and you can do that. Now here what I'm doing, guys, here you can see we are going to be define some training argument. So the training argument, I'm going to be keep the output directory where I'm going to be keep my fine-tuned model. Number of epoch, how many number of epoch you want to be run. Per device trained batch size. So it is like we are going to be define the batch size over here. Per device means if we have a multiple GPU devices, according to that also we can according to that means on top of other different devices, this particular batch size is going to be executed. Okay, so per device trained batch size means like as of now we just have single device on while we are going to be trained, right? So 8 batches data will be passed in 8 batches. Okay, in one single batch the 8 data point would be there. Then logging directory, so all the log will be captured over here. Learning rate, this is my learning rate, it is a small learning rate. Decay rate, okay, so it's a decay rate means it is related to that optimizer, the optimizer we are going to be use. So with this particular decay rate, my like the weight is not going to be fluctuate too much. Then report none, we are not going to be like capture anything anywhere. Okay, by default all the details is going to be captured over the weight and biases dashboard, over the TensorBoard dashboard. We are not going to be capture it anywhere, okay, the details and all. So here my training argument. Now what I will do, guys, I will create my trainer. So here I will pass my model, the model which I loaded over here. This is the BERT-based model. Okay, here you can see this is the base model. Now in the base model we just have 12 encoder. You can check out the complete detail over here if you are going to be uncomment this entire code. Okay, so you will get that. Let me comment this line and let me comment this line. You will get all the layers basically. So how you can get all the layers? Simply you can run this one, this for loop. So if you are going to be execute this for loop, you will find out the parameter. So let me print the parameter, how the parameter looks like. Let me check regarding how many layers it is showing the parameter. So here it is saying model is not defined. I haven't loaded the model. Okay, at the first place we'll have to load the model. I have loaded the model now. Model is there. Okay, I think it got disconnected. Let me execute it one more time. So this is done, this is done, data set is there. Just wait, guys, let me load it one more time. Maybe the runtime is disconnected and because of that it is showing none. Okay, let it be load. Okay, so guys, after loading the model, you can see the complete layer, all the layers of this BERT model. So in total, in the base model, we have 12 layers. You can check out the length of it, see, or else you can count it like this. So this is all the layers, okay, all the encoder layers. So this is all the thing I have explained in my previous video as well. If you will go and check over there also, you will find out the complete detailed overview of it. Let me comment as of now this particular thing, it is not required. So training argument is completely clear. Now our trainer, in the model trainer we are passing a model, we are passing up arguments. Okay, here we are passing a data, training data and the eval data. So this was the data as I shown you just now. So in the data basically we have training data as well as the evaluation data. So see guys, this is my training data, okay, and is my testing data. We have created a tokenizer. What is the use of it? To convert the data into the tokens and assign appropriate numbers. Okay, then here we are going to be process the data, we are going to be process, so we are going to be map with the tokenizer, then we are going to be convert into this formatting, this format. We have a PyTorch tensor, we have an input ID, attention mask, and this labels, right? And then we are going to be return. So likewise we got the train data, okay, and here is what, here is my test data. Now I hope this is clear to all of you. So this particular data I'm going to be keep it over here. So here is my train data and this is my test data. Okay, now once I will run it, so my trainer will be created and on top of it I'm going to be called this train. So guys, here now my model training will be started. I just have a very small data set, that's why it is not taking much time and it is like training it very fast. After that guys, what we can do, we can visualize this tensor board. We can check out with the log directory if the log directory has been created. So yes, see BERT fine-tune IMDb, this model have been, this particular directory have been created. Under this I will be getting my checkpoints. If I want to save the model manually, I can do that also. I'll show you right after the training how you can save the model basically manually. So see, this is the code for saving the model manually inside the directory. Inside the same directory you can save, or else inside a different directory also you can save. It's up to you wherever you can save it, right? So trainer.train, and see over here the training has completed. Now after that, with this tensor board, I can check out, I can visualize the log, I can see the visual of it. So see, first of all, let me show you the log directory also. See, this is the checkpoint. The checkpoint have been created. Now if I will refresh it, so log directory also will be created. As of now it is not created, it will be reflecting in some time. Let me execute this one, let's see whether it is coming or not. So syntax is not correct. Let me check out with this exclamation mark, and yes, so it's working. It is not reflecting over here. Maybe it might take some time to reflect over here, but yeah, it would be there, and then you can visualize every sort of a log, okay, using this tensor board, right? So see, tensor board is running on top of it. You can check out on this link, and over here guys, see, as of now nothing is visible. It will be visible at some time. Okay, I think we are running it over the collab, and it won't be available over the local host. Fine, I'll be checking how we can visualize this one. Now coming to the next part. So using this particular one, trainer.save model, we can save the model. Okay, manually we can save the model. Here you can see we just have the checkpoints. Okay, if you will look over here, we just have checkpoint means at a specific step, till the specific step, we are going to be save the state of the model, not the complete model. So using this one, this command, we are going to be save the complete model. Okay, trainer.save model. Now here trainer tokenizer also we're gonna save. So let me save the tokenizer also, and let me stop this as of now. I'll come to this one later. This one basically tensor board, how we can visualize all the stuff, all the thing, all the detail. Okay, now see, my model is getting saved. Okay, so apart from the checkpoint, you can see the complete the other detail. My model and my tokenizer have been saved over here, this one, right? So model is there, tokenizer is there. Now what we'll do, so we are going to be evaluate the model. So once I will call this trainer.evaluate, on top of the test data, my model is going to be evaluate. Okay, so we will find out the complete accuracy details and all, right, inside this matrix. See, inside this matrix we have a evaluation loss, evaluation runtime, okay, evaluation sample per second, evaluation step per second. So this is the loss. Okay, how much loss we are getting? This much of loss we are getting with respect to our evaluate dataset, the dataset, test dataset which we have provided. Now if you want to make a prediction, so what we can do, simply we can load the model, okay, from wherever we have saved. So we have saved this model over here. So this is my checkpoint guys, as I told you, and here is my complete model. Means after the training, whatever model basically we have saved, you can see over here, it is reflecting over here. Okay, now we are going to be load it. So content BERT fine-tune IMDb, okay, content BERT fine-tune IMDb. So tokenizer and model both we are loading from here. Now here we have a pipeline. So in the pipeline we are passing this text classification, model and tokenizer. So this pipeline I already explained in my previous video in the HuggingFace itself. If you haven't checked that, please go and check. Now I am passing my text. Okay, this movie was amazing and I love the acting. So here I am going to be classify it using this classifier, okay, where I kept my own custom model, own fine-tune model. So once I will execute it guys, it is saying classifier not defined. So first I will have to execute this one, and see, the classifier is there. Now see, we are able to get the result also. I can simply visualize the result. So label is 0, score is this much, means it is a positive review. Okay, I hope it is clear to all of you. Now if you want to push this particular model, the train model, over the HuggingFace, so this is the command for this one, pushing it to the HuggingFace hub. So once I will log into the notebook, we'll have to log into the notebook with the right token. Okay, in the previous HuggingFace video I already explained you, if I want to write anything over the HuggingFace, I will have to use the right token. So now I can check what kind of permission I have. So if I will execute this who I am, so I will get my entire detail, my account detail. Okay, and here you will find out the detail of the token, right? So you have the right permission now, because we have a login with the right token. Okay, now I can simply push it. So my BERT IMDb, so I can push it to my repository, my BERT IMDb 2. Okay, and here is also 2, because I have already pushed, I already checked that. So I'm pushing it with a different name now. So if I will execute it, see, tokenizer is getting pushed, and here I can push my model as well. Okay, so simply you can check out with the HuggingFace. Once you will run this, write this HuggingFace. Okay, and if you will check out with your specific account, see, my account is this Sunny199. You can see the detail of my account. Let me open that. Okay, so here my account name is Sunny199. Once I will check with the account, okay, just click on it, and here you will get all my models, whatever models I have pushed just now. See, here is my BERT IMDb 2 model. Okay, this is the model, and here you will find out a tokenizer also. So tokenizer and model both have been pushed over here. So my BERT IMDb, this was the earlier one 2 days ago when I was practicing. I was able to push it, and this is the latest one. Okay, tokenizer wise, I think I will be getting in a same repository. So NER model, okay, I will be getting into the same repository by BERT IMDb 2. So using this one, this particular ID, we can load the tokenizer as well as we can load the model as well. So if you will look into the file and version, so see, every sort of a detail, see, tokenizer is also here along with the model. So model is there and the tokenizer is also there, guys. So both you can push and you can load at whenever it is required to you. I hope this is clear to all of you. Now coming to the next part. So here, guys, not only for this task, not only for text classification, we can utilize this BERT for any sort of a task. We can basically fine tune it for any sort of a task. Okay, so here, guys, you can see, let me execute it one by one, step by step, and then I'll come to the explanation of this as well. So here is my device is my CUDA. Okay, this is the different basically classes which I created for the different kind of tasks, right? Now let's say if I want to be fine tune my model on the classification, which I already shown you, I will simply press 1 and my model loading and all, everything will be started, and it is going to be fine tune the model. Okay, see, my fine tuning has started. For what? For the text classification. Okay, now if let's say if I want to be fine tuned, I'm just going to be stop the process. Let's say I want to be fine tuned for the NER task, so simply I will put 2 and I will hit enter, and see, my fine tuning have been started for the NER task. Okay, so this is the one custom generic code which I created, so that see, my fine tuning have been started for the NER task as well. Okay, now let's say if I want to be fine tuned for what? Let's say if I want to be fine tuned for the question answering. So simply I will put 3 over here and I will run it and see, guys, what is happening. My fine tuning have been started for the question answering task. So for any sort of a task, for whatever task I want to be fine tune my LLM, this BERT model, I can fine tune with this simple generic code. Okay, and if I want to be fine tuned for all the tasks in a single shot, let's say so for that you just have to press 4 and it will be fine tuning my model for all the tasks. Okay, so see, it has started for the classification, then it will be started for the basically the next task, which is basically NER, then question answer and all. So for whatever task you want to be keep that code, you can keep that particular code. So let me give you the walkthrough of this modular code, the entire modular code. So if you will check, okay, I will give you the walkthrough of the one single class. Rest of the class you can explore from your end. So here I have the BERT. Okay, so I have the NER data. So see, we have 2 ways of creating a data set. The first way which I created over here, if you will look into this particular code, so into this particular code, what I am doing, I am going to be pre-process the data like this. Okay, so this is a way of pre-processing the data, this one, pre-process, and we are going to be map it, we are going to be rename the column, set format and all. But guys, apart from this one, we have one more Pythonic way, the PyTorch way. Let me show you that particular way, PyTorch way. Okay, so here if you will check with this particular class, what I have done, I have created a class, the text classification dataset. I'm going to be import this dataset. This is from the HuggingFace. I've created a init. So this init will be initialize this text, label, tokenizer, and max length. Okay, then we have a length. So this length will return the length. Okay, length of the length of what? Length of the data set. Get item, it's going to be written, it is going to take text, label, it is going to perform the encoding, and it's going to be written this input ID, attention, and label, the same thing which was written in my previous code, right? So if you want to understand this dunder method, so here I kept one dummy code so that you can understand the meaning of this dunder method. So we are going to be initialize on the class. Okay, as we have created an object, so this class will be initialized with this list. Okay, length, basically I'll check the length. If I will put the len on top of this object name, I will get a length directly. If I will put the 0 1, I will be getting the specific item, okay, using this get item. So this is one generic class I've created to all of you. You can understand first you can understand this basic class, and then you can go through with this particular class. Now where I'm being used this specific class, let me show you that as well. So here guys, you can see this is my main class, BERT classifier. So this class is having 4 to 5 things. First we are going to be initialize the classifier, loading the data, training the model, evaluating the model, and predicting a new text. Okay, so here you can see this is the initiating the class, where I have a model, number of classes, max length, tokenizer, and model, and all, and we are going to be set it to the CUDA or CPU, whatever. Here we are going to be load the data set. After loading the data set, see, we have load the data set, then we are taking a sample, then what we are doing, we are going to be taking the train text and train label, okay, over here using this code, right? Train and test for both data. Then from here we are going to be written. Now we have a train function. This train function, what it is doing, it is going to be initialize the data. See, this is the data set. This is my class, the custom class, where I am passing my data, text, train, okay, train text, train labels, and it is going to be written the appropriate object, whatever basically I'm going to be written from the get item. Then here I have a train loader. I'm going to be load the data. Now here is my optimizer, guys. So this is my optimizer. This get linear schedule with warm up, it is for the basically learning rate is going to be set automatically using this particular function. This is one inbuilt method over here inside the HuggingFace. Then I'm going to be set model as a train, and here my model training is going to be start. In model training, guys, first we are going to be pass the data, then we are going to be calculate a loss, and then here is my optimizer which is working. So once the model will be trained, I'll get my model, okay, I will get my model, then we can evaluate my model. See, here is my prediction, here is my true label. We are not going to perform any sort of a training, we are just going to be evaluated over the test data. Okay, so everything I'm going to be written, accuracy, F1 score, and the complete report from here. Then prediction with a single data point. So prediction will be there, prediction probability. So here I'll be getting my text, we're going to convert into the encoding, we are going to be perform the prediction, and here I'm going to be written that. As simple as that, guys. So this entire thing is going to be drive using this particular method. Let me show you the driver method also, driver function of it. So run text classification demo. So here I'm going to be print certain information, then I'm going to be create a object of it, object of the BERT classifier. Here I will be loading the data, I will be getting this train data, train text, train label, text label. Okay, then I'm passing it to the train. So everything is being trained, then evaluate would be there, and then here. So here, guys, we are going to be predict the custom review, means after training the model, what we'll do, we'll make a prediction on top of these particular review. So this is there inside the run text classification, and my code is going to means we are going to be iterate on top of this review, and we are going to be make a prediction whether it is a positive or negative, right? So guys, similar to that, we have created for the NER, we are doing for the QA also. So I hope this entire code is clear. Once you will go through with it, you will be able to understand. I'll give you this entire code. So yeah, this is it for this particular video, guys. In the next video, I'll show you the concept of the distillation, and then we'll learn about the quantization. So until, thank you, bye bye, guys, take care, have a great day ahead. Thank you.